to the next session of Exploring Physics. Great applause to the few students who have completed the assignments. I hope other students will also join together and submit your upcoming assignments on time. So, do you all have the note and pen with you? I think yes. What is the first lesson we are studying? Matter. In matter, we have studied about two topics, right? One is kinetic theory of matter and another is three states of matter. Before we move on to our next topic, we will enrich our vocabulary quickly. When water is being heated, what you can observe? You can observe the bubbles are coming, right? And the water will also be turned into water vapor. How do we call this process? We call this process as boiling. Boiling is the action of bringing a liquid to the temperature at which it bubbles and turns to vapor. What is this? This is a piston. When we are applying some force to the piston, the air present inside the piston, that is inside the cylinder, will also exert some opposite force to our applied force, right? You can see it here. The air inside the cylinder is also exerting some opposite force to this applied force, right? So what it is called as? It is called as pressure. The pressure can be defined as the force that a liquid or gas produces when it presses against an area. We can also define pressure as the force you produce when you press something. When the number of vehicles in the city increases, the carbon dioxide emission will also increase, right? How can we frame that sentence in an accurate manner? The carbon dioxide emission is proportional to the number of vehicles. What is the new word? Proportional. If two amounts are directly proportional, when one increases, the other also increases, and when one goes down, the other goes down. We will start with the activities to start our learning. Take an ice cube and keep it outside. After some time, what you can observe? You can observe that the ice cube get melting into water. So what is the change of state which is happening here? Solid state, that is ice, is getting melted down to liquid state, right? What is the process happening here? So we know that melting process is happening. Now, boil some water in a pan. What you can observe after the water is boiling? You can observe that water vapor is forming, right? So what is the change of state which is happening here? Liquid state, that is water, is being converted into gaseous state, right? How this process is called as? Vaporization. We call this process as vaporization. Now, close the same boiling water vessel with a lid. After some time, what you can observe? Can you notice anything in the lid? You can notice small water droplets being formed inside the lid, right? Why these water droplets are forming? These water droplets are formed because of the water vapor coming from the boiling water. When the water vapor falls on the lid, it gets cooled down to form water droplets. So what is the change of state which is happening here? Gaseous state is being converted into liquid state. That is, water vapor is being converted into water droplets. How do we call this process? We call this process as condensation. How do we call it? We call it as condensation. Now, let us pour some water into the tray and keep it in the freezer. What we can observe? We can observe that the liquid which we poured getting converted into ice cubes, right? So what is the change of state happening here? Liquid state, that is water, is being converted into solid state. How can we call this process? Do you know that? What is happening here? Freezing is happening here. So definitely it is called as freezing. let us take some camphor and keep it outside in open space without any covering. After some day or two, what you can notice? What will you notice? Actually, the camphor would have disappeared. Why the camphor disappears? Because the camphor, that is solid state, is being changed into gaseous state in the normal setup, in the normal room temperature setup. So that's why the camphor disappears. So we call it as sublimation. The camphor, that is solid state, is being sublimated to form gas. Right? All of you are having note and pen with you. Take down these important terms, that which term is used to represent which transformation. You should be clear in that. Solid state to liquid state, we call it as melting process. Liquid state to gaseous state, we call it as vaporization, right? Why? Vapor is being formed. Gaseous state to liquid state, we call it as condensation. Solid state to gaseous state, we call it as sublimation, and liquid state to solid state, freezing. It is very important to remember the right terms for right transformation. If you are connecting with the appropriate example or phenomena, it will be very easy for you to remember. For example, melting, ice cube melting, vaporization, example, boiling water, vapor is being formed, condensation, closing the boiling water with the lid, water droplets are being formed, sublimation, example, camphor, getting disappeared, freezing, yeah, getting the ice cubes. Make sure to remember these terms. I think you would have guessed now what we are going to study deeply today. We are going to study about change of state. Why each change of state is happening, how it is happening. Do you know which is the biggest environmental concern in today's scenario? It is global warming. Why the global warming is happening? Because the temperature of the earth is getting raised. Why the temperature rises? Because of the human activities. We release so many harmful greenhouse gases into the earth, which rises the temperature of the earth. But why does it matter? Why do we bother when the temperature of the earth rises? Definitely it will affect us. How? It can cause so many destruction because sea water level will get raised, and countries which situated across the sea water may get destructed. So how the sea water level rises? Because of the melting process, right? Because the ice glaciers which is present in the Arctic and Antarctic region, they get melted down to form water. So the water level get raised. What is happening here? Melting process is happening, right? So in melting process, the solid state is being converted into liquid state, provided what? When the temperature is raised. When the temperature of the solid is being raised, it gets melted to form liquid state. We have already studied one thing. When we supply heat energy to the solid, what will happen? The particles in it become energetic and they move away from each other. When the particles move away from each other, it leads to expansion of the solid, right? We have already studied it in kinetic theory of matter, and also while we are studying three states of matter, right? But what happens when we supply more and more heat energy to the solid? When more amount of heat energy is applied, will the solid grow bigger in size? No, the solid will not grow bigger in size. When more and more heat energy is being applied, the particles move away from each other. They move past each other, right? So, which changes the solid state into liquid state, right? Only in the liquid state, there is some intermolecular space, right? So, the solid state is being converted into liquid state. Shall we visualize what happens to the particles of the solid when more and more heat heat energy is being applied? Now I have chosen solid state. Now I will slightly rise the temperature. So 14 Kelvin is being raised to 15 Kelvin. Now there is no much changes, but the particles are moving, right? Still they retain some position. So there is only expansion happening here. But if I am increasing the temperature more and more and more, the particles move past each other. At 28 Kelvin, they become liquid, right? When the temperature is being increased, the intermolecular space between the particle increases and it reaches the liquid state from solid state. So this is how the transformation is happening. We have to note the temperature at which the solid state starts melting. What is melting point? The temperature at which the solid starts melting is known as a melting point of the solid. I think you're taking note of this. The temperature remains constant until the entire solid get melted. How can we prove that? So this is the ice cube and I'm supplying heat energy and I am measuring the temperature when the solid starts melting. I say it as T1. Now the temperature should be measured just after the entire solid get melted. So through this process, the heat energy is continuously being supplied, right? So the temperature is measured just after the entire solid get melted. We say it as T2. But we can observe that the T1 will be equal to T2. That is, the temperature remains constant until the entire solid gets melted, even though the more heat energy is being supplied. So take note of it. The temperature of the solid does not rise, even if the solid continues to be heated until the entire solid melts. What is the important thing? The temperature of solid does not rise, it remains constant. What do you think? This melting point is based on what factor? What determines the melting point of the solid? It is the intermolecular force between the particles. When the intermolecular force is high, it will be tough to overcome the intermolecular force. So the melting point will be very high. That's why the ice melts at 0 degrees Celsius, but the iron melts at 1535 degrees Celsius. Why? The intermolecular force in ice is lesser, weaker than the intermolecular force in iron. It is very stronger in iron. So, in ice, it is very easy to overcome the intermolecular force. So, the melting point is very low. The temperature at which the solid starts melting is very low. But iron, the intermolecular force is very high and we have to supply more and more amount of heat energy. So, the temperature at which the iron starts melting is very, very high. That is 1535 degrees Celsius. Now we have found that melting point depends on the strength of the intermolecular force that binds the particles. It is usually more in metals than in non-metals. That's what we observed here also. Iron is a metal, ice is a non-metal, right? So it is more in metals, but it is less in non-metal. Is it possible for us to decrease the melting point? Yes, it is possible. How? By adding salt to the ice, it actually lowers the melting point and the ice melts soon. Adding any solute to the solid lowers its melting point. In colder countries, the roads will become icy and they have to get rid of the ice for the easier transportation. So the people living there use the salt to melt the ice soon. adding salt lowers the melting point. Shall we write down the important points to remember on melting? Expansion of solid happens on heating. So how the melting is happening? It's because of heating. When we are applying the heat continuously, the particles are moving past each other. That's why the liquid state is being formed. The temperature. We also studied what is melting point. The temperature at which a solid starts melting is known as the melting point of the solid. After the melting point temperature, the temperature does not rise even if the solid continues to be heated, right? Until the entire solid melts. Energy supply changes the solid state into liquid state. What is the next topic we are going to see now? I think you should have guessed. It is freezing, right? The water, the liquid state has been freezed to ice, solid state, right? What is the reason for this freezing to happen? Because the temperature has been lowered very much, right? What happens to the particles of the liquid when the temperature is being lowered? That is, when it is being cooled. When the temperature is lowered, the particles come close to each other. When they come close to each other, what happens? The intermolecular force binds them. When the intermolecular force binds them, what state it is reaching? It is reaching the solid state, because only in the solid state the intermolecular force is very high, right? So on the cooling process, the particles come close to each other for the intermolecular force to bind them. That's how the change of state is happening. We have to measure the temperature at which the liquid starts freezing. What it is called as? It's called as freezing point, right? The temperature at which the liquid starts freezing is known as the freezing point of the liquid. It is something similar to the melting point. In the melting point, that is defined as the temperature at which the solid starts melting, right? That is known as a melting point. While studying about melting process itself, we studied that the temperature remains constant until the entire solid melts. Similarly, in freezing also, the temperature remains constant until the entire liquid getting freezed or getting solidified. How? How we say that? We should measure the temperature when the liquid starts freezing. We say it as T1, and we should also measure the temperature just after the entire volume of liquid solidifies. We measure it as T2. We can observe that T1 will be equal to T2. So how can we observe this? Using an experiment. So shall we devise an experiment to do this? So to prove that the temperature remains constant until the entire molten wax solidifies. So we will take wax and we should first heat it to melt the entire wax. So just after the melting process, we have to turn off the burner. Now what we are going to observe? The freezing of the wax, right? So we have to take the thermometer and note down the temperature of the wax till it get solidifies. What we can observe, so have put it in a graph. In a graph we can observe that the temperature lowers first because of the cooling process, right? After some time, the temperature remains constant for some time. That's where the freezing starts and the freezing ends here. So the temperature remains constant when the liquid starts freezing till the entire liquid solidifies. After the solidification process, the temperature falls down. So, during the freezing process, there is no falling down of the temperature. What happens to the energy of the liquid where it solidifies? Why this question arises? Let us explore. You can see that the liquid state is having higher amount of kinetic energy, but the solid state is having lower amount of kinetic energy compared to the liquid state, right? So when the liquid state is being converted to the solid state, what happens to the remaining energy in the liquid state? It is actually given out as the heat energy. So when the water solidifies to form ice, what is being given out? Heat energy is being given out, right? This heat energy is being utilized by the farmers living in the cold regions to safeguard their vegetables from the cold. Do you know what they used to do? The farmers used to keep the barrels of water in their storeroom in which they store their vegetables. This, when the water solidifies and forms ice, what is given out? Heat energy is being given out. This heat energy is being used to safeguard the vegetables from the cold. Is it possible for us to lower the freezing point of the liquid? Yes, it is possible. Similar to the melting point, because we can also lower the melting point by adding solutes, right? So similar to the melting point, we can add solutes to the liquid which can lower the freezing point of the liquid. Shall we write down the important points to remember on freezing? How does freezing happens? When the temperature is lowered, the particles come close enough to each other for the intermolecular force to bind them, right? Temperature remains constant until the entire molten wax, that is liquid state, solidifies. What is known as freezing point of the liquid? The temperature at which the liquid starts freezing is known as the freezing point of the liquid. Heat energy is being given out during the process, which is utilized by the farmers living in the cold region to safeguard their vegetables. Adding solutes to liquid lowers the freezing point of the liquid. We have completed our learning on melting and freezing. We will study about the rest of the changes of matter in the next class. We will discuss few questions on matter. This is the assignment question which I have given you for the previous week, right? Compare the properties of 3 states of matter. Actually, there are other properties also which is clearly mentioned in your books. So refer, write books. You can also draw the appropriate diagrams when you are comparing. What is this question? What do you mean by intermolecular spaces? How do they vary in different states of matter? This we studied in last class. We know what is intermolecular space, so read through this answer. Here is the question to differentiate between melting point and boiling point, giving at least one example of each. They are asking us to give the example also. So we have learned what is melting point and boiling point, right? You have to differentiate. Next question is, describe an experiment to demonstrate that the substance absorbs heat during melting without change in its temperature. We have studied, right? During any change of matter, the temperature will not rise. It will remain constant. They have asked particularly that during melting, the substance absorbs heat. We know that, right? Only after absorbing the heat, the melting process can happen. So they are asking us to devise an experiment. So this is also an easy experiment. Read through. Let us see the assignment questions for this week. First question is, distinguish between melting and freezing. Second question is, Describe an experiment to show that temperature remains constant during the process of melting. Both the questions are very easy. You can easily submit it on time. So do submit it using the GCR. Take care of your health. See you in the next class. Thank you for listening to the class.